All right, here we are. Hey, everybody. Good to be back in the depths of the summer. Got some vacationers this week, but we have a good turnout, and I think Ling will probably join in a second, as she indicated. But just want to say, hey, everybody. Jay, you and I caught up for a few minutes before the stream started. I hope all is well.
Yeah, very good. Yeah.
Fantastic. And then we got Charles at UT. Charles, I'm back in Austin as of a couple of days ago. So I was going to Discord your WhatsApp you to see if you wanted to get together for pizza or for coffee or something like that next week, maybe.
I will be in Austin in about 2 weeks.
Okay, cool. So we can hold off till you get there. And then we got Will, who's joining for the first time, who I've heard so much about. So great to have you join us, Will. How's it going?
Pretty good. Can you hear me all right?
I can hear you perfectly. Yeah. So, Will, I've talked to Ben and Charles and Aiden about you, and was so excited about the nature of the work that you're doing and how it overlaps with what we're trying to pull off here at Epiphyte. So, I was wondering if you could just two things. One is just let us know how much you know about the project, but really eager to hear a little bit more about your sort of bio and what you're working on as a postdoc at UT.
Definitely. Oh, so actually, I'm currently not a postdoc yet, I guess, technically. I'm in my 4th year as a graduate student at UT, and I currently work in the Bones group, so we're kind of like half chemical engineering, half chemistry.
Okay.
I specifically synthesize porous carbons for CO2 separations, or N2 CO2 separations. One thing that's unique about our lab is that we are one of the few labs that have any of these like adsorption instruments that can actually dose in gases, see how much uptake we have for material, measure things like surface area, CO2 uptake, N2 uptake, those types of things. So we're kind of like in a unique position because not many other people that I've found on campus have been able to do the stuff that we do. So that's pretty unique. In terms of the project for like what Charles and Ben and all that have been doing for the undergrads, I've been helping them out with just trying to synthesize their chemicals for it. So what the sequestration compounds that they're trying to use, we're trying to make this moth made out of a paper that I found. So it was like it was a metallurgic framework. It's something that I haven't synthesized myself, but it's something that we were interested in. And then recently, Tommy, that's part of this group as well, mentioned that they wanted to use a different chemical, and I actually do have a little bit of experience using it. It's like a branched polyamide, ethylene polyamide compound, I believe. And yeah, that's currently where I'm at in terms of what's going on with the project. So
fantastic. Well, Will, again, we were absolutely excited to hear about you, and really looking forward to meeting you. You in Austin right now, or are you out of town till school starts?
Nope, I'm here. I'm actually in lab right now. I'm just sitting down at my desk.
Cool. I'll shoot you an email after this, but it'd be awesome to. I'm so happy to be back home. I've been gone for the last 2 months, roaming from place to place. So just got back recently, but would love to. I'll shoot you a message, but let's go grab coffee when you're free, so we can kind of get down to some details. Hey, Ling.
Totally.
Cool. So what? I know, Jay, you had a really long thread going on the Discord with a few folks. So would love to hear from you on that. But what I thought I would do, Ling and I got to meet up in person. Some pictures were taken. Coffee was had in Brooklyn, which was awesome. You're taller than I thought you'd be, Ling. But that was nice. Really nice to have that. But, we talked about a few things. And what I did a little bit more sort of product research, Ling, and talked a little bit more with Kirsch on WhatsApp. So I wanted to share just a few slides here about possible hacks we can do in the direction that we've been talking about. And Will, you're dropping in right at the perfect time. So Ling, I don't know if you caught that, but Will is finishing up his PhD in chemie and chemistry, and he's the guy who's been synthesizing MOFs and working with the other UT teams. And he just mentioned something that I wasn't aware of, that apparently there's some pretty rare tools that they have in their lab. This is about as smart as I get, Will. So you'll have to explain the relevance of that when we get to it in the conversation. But always good to know. But yeah, let me just share some slides, and it'd be a good way too for you. Will, have you seen any of the videos at all of Epiphyte? Like just the basic overview, like tour of the one we built at UPenn?
No, I have not yet. I'm interested. Yeah.
Let me just show you a couple pictures, and then we'll very quickly kind of run you through some of the things we're trying to change. So if you can see that picture there, that's the first prototype we built, which we just built it with an HVAC filter box that you normally slide like a HEPA filter or a MERV 13 or something into. Okay. You'll notice dampers on the two sides. You can't see the CO2 sensors that we had integrated in there, but those have been added. And then on the far end, that's a fan, right? So okay. On the insides of it, we have that little part you see in the middle, the square part. What slided in before was basically what we called our sorbent cartridge. Those are nichrome wires that are going through. This is our first kind of attempt at it. You'll understand how much we learned through this and the changes that we're going to make, but just to give you a baseline. And then we had a zeolite sorbent that we put on top of that, and we sealed it. And then you'd turn it on, and air would flow through for absorption. We'd shut the dampers, and then we'd heat it up with the wires. Now, you probably instantaneously realize some of the downsides that we discovered through this. Zeolite's not a great sorbent for this; absorbs more water than CO2. So very quickly we decided to move on from that. We upgraded our sensors to something that caused sort of less turbulence and was easy to get clear readings off of. So we have that, but we also had issues around airflow. When you have that dense pocket of durable food there that we're looking at. That blocks the airflow through it. So we wanted to go with a different approach on several different fronts, which we've summarized many times before on these calls, and I can send you our little web page that sort of summarizes what we're trying to change. So the top things we really wanted to go for was a different sorbent, a different way of integrating the sorbent into the system. For a couple of different reasons, but one being so that the airflow could be maximized. And then we also had the sensors I said we improved. And so what we've done over the last several weeks, this wrapped up in December of last year. So the plan has been, okay, let's come up with solutions so we can fix the UPenn version enough so that a team there can keep using it. I'm actually going to UPenn next month for a conference, so I'll see it in person for the first time. And then let's build our next one at UT. I'm based here, and you got these amazing people like Charles and Naden and yourself. And I won some money through the Bezos Climate Prize that could fund that build fully. So,
great.
Yeah. So anyway, just to drop that on you, I wasn't sure how much Charles or Aiden told you, but it would be so exciting to have you, involved to the extent you want to be, because it's funded and we can have a lot of fun doing it. I think.
Totally, I'm on board. That sounds great.
Fantastic. Invite some friends. So the thing that we just a couple of things that this sort of kind of brings together a lot of the stuff that we have been thinking about in the past, right? So after we had what we called the Hello World build, we got, a trace indicator that some carbon was captured, and yay, but it was nothing even remotely functional, in a way that we'd want to share the full open source, like really kind of try to get a lot of people to build it. So we wanted to make these fixes this spring and summer. And we had considered possibly like really starting from scratch and looking at an entirely different, sort of form here as a basis. But since in recent weeks, we were able to get an amazing OpenAir member named Kirsch, who's also he's the chief scientist for Clarity Tech in LA, a DAC company. And so I went and visited his lab, and they had something that looked a lot like our Epiphyte, the shape of it. And so we were like, okay, well, why did you do that? And so it kind of encouraged us to kind of stick with the basic form, but to maybe make some sort of changes, right? So one of the things that's interesting about this, since we're just using an existing AC filter box, is that they're meant to fit, a filter cartridge in there. And so we thought, okay, could we possibly use what already exists? And the other thing that Kirsch provided us with, what was really important that we've decided to go towards, is to go, instead of just dumping a bunch of pellets of assorbent in, is to go with a ceramic honeycomb monolith and go through like a wash coating type of process, which I think it'll make it way more efficient, but it allows the air to flow through a lot easier. So let me pause there for a second, and I hear encouraging, yeah. So you agree that that's the right approach to? You probably have some experience with that too, I'd imagine, right?
Yeah, totally. So it turns out, Ben, they had kind of like a similar DAC like unit that they built themselves for like a project they had. Maybe this was over a year ago now. I don't know if you ever got a chance to see it, but they had like kind of just like a bed of cotton, I think it was, and then they poured. I think they also used Zeolite 13X as well as like just a proof of concept that was working. And when I came in and I was helping them out with trying to, make the bed or whatever the contact surface for the adsorbent better, I came up with this. I found the same idea as well with the alumina monolith, almost like a catalytic converter, right? Like if you cut open your car's catalytic converter and you have all these like little channels where air can flow through, that like maximizes surface area that can pass through and touch your adsorbent without like restricting the airflow as much. We never got around to actually getting to the point where we could get like the alumina blocks to machine them, do all that. Just a lot of like resources. It was mainly the cost because we had to either buy a pre-made honeycomb or try and just buy a block of alumina and see if someone on campus could machine it for us. We never got to that point, but we were making the mock that could then be seeded onto the alumina because this block, you can buy it made out of just alumina, and when you can then actually build your mock on top of that. So you can then grow seeds essentially and coat the whole entire, I think you were mentioning as well, like kind of just like coat the surface with whatever adsorbent you want. It's kind of difficult depending on which one you're using, but I found that organic framework from a paper that I read was able to go onto the alumina surface, and it looked like a really good idea. However, we never got to that step, but this is basically the same idea that we had as well, and I think it's a really great idea. Yes.
Awesome. And with the MOF stuff, I mean, we've been really excited about MOFs for a while. I don't know if you know, like the USORB project that Susana Garcia Lopez does out of Harriet Watt University in conjunction with a few other universities, but it's this like kind of like a AI platform that when people synthesize MOFs for DAC, they can upload it and they're able to sort of show what are the optimal conditions for deployment. And then as they keep building their library, it gets smarter and smarter. So she was saying, MOFs are really exciting. They're just kind of expensive and rare, right? And so, but what we want to do with this is to have it be, if it's a monolith-based system, is that it can be a tool for testing different sorbents. You know what I mean? So you just pop another monolith, and test it out. So what we want to do now for this first build, unless you think, we have what's potentially required to go with a MOF, right off the bat for the UT one, we were going to go with something that's available and good enough. And Kirsch had recommended, these two here. So he said, a PEI with a SBA 15 mesoporous silica. I'm not a scientist. And he said you'd sort of coat the silica first and then the PEI. So I don't know if he just recommend, again, given the brief, like we want something that works, but it's the beginning, not the end. And it would be a major upgrade, obviously, from the, from the first sorbent we used, the zeolite. Is this kind of combo familiar to you, or one or the other? Or?
Yeah, I'm actually kind of surprised that this. I mean, if Kirsch recommended it, I'm assuming it works. I wouldn't have thought off the top of my head that this would have worked. Actually, to be honest, I don't. My only concern is like how well does it stick onto it, right? Because alumina is just aluminum and oxygen, and then the silica would kind of be like, you can think of it as like almost like in between, like a emulsifier almost for like paint, just kind of like a filler almost that would then branch the we can call it PEI, the branch poly amine. The PEI would just be stuck onto the silica, and then the silica would then go onto the alumina surface. That's also assuming that we're using an alumina monolith, which I'm assuming it is. I don't know if Kirsch had given you any details of it.
Yeah, he's the one who got me onto it. I had never even heard of it before. So he showed it to me in his lab, and that was what got us onto this course, and everybody agreed, yeah, let's do that.
Okay.
So this was just what he suggested over a WhatsApp chat. So, we're wide open. We're obviously have some cost constraints. So, but we should be able to afford, we could get something in there. We just gotta, think about something that what would the next build use so that it's not like a huge fortune. But over
Yeah.
coffee and subsequent conversations, you can, let us know what your thoughts are on, what might be an alternate. Unless you want to, I mean, I don't know how much, as you'll see what we show you in a second, it's a small system, but are you in a position to actually synthesize MOFs of a certain volume that could be used for like a small demo system like this? Or is it really, are we talking about like the milligram level?
Yeah, I think we're still on the small scale. It depends. It really just depends on how much precursor we can buy. And if we can buy grams of it, then we can definitely synthesize grams. It's just the cost. Because the one I tried buying, we were in the scale of like hundreds of milligrams just to test it out. And that's kind of where we ended last semester with the DAC team. Just like doing the preliminary, hey, can we even like make this? And it's actually not that difficult to make. You don't need any crazy like strong vacuum pumps or anything. No chambers. You just have to really just heat it up, put it in a little vial, and let it grow. And that's pretty much it. It just depends how much we can buy up front, really, and how much bulk we can get. With this stuff, though, the PEI, this should be super doable, though. And I think it'd be cool to test this to see how strong it is. Because it's really that like anchoring thing where like how strong the PEI can get stuck to the surface through the silica or whatever medium that you want in between. Because that's, I think, really the most difficult part. Because my concern is how strong that is, and over time, like how much will it degrade, how much will it get ripped off when you heat it up, and when some of it come off, will it also degrade during the heating cycle? There's lots of factors to consider with that too.
Well,
Yeah.
when Kirsch, I was in his lab, and it's not like a university lab; it's a startup lab, and he's sort of over in one corner, and he was explaining the process, like the wash coating process and the calcining. I can't remember what it's called, but that end to end to embed sorbent into a monolith like this isn't particularly out of reach. Like it's good to have a lab environment to do it. Would you agree that it's relatively, like if we were to do it at UT lab, like it's not too much of a stretch to be able to do something like that?
Oh, totally not. Yeah, I could definitely do. If I had literally had the materials right here in front of me, I could do it. Yeah,
Okay.
that's just that's just the issue. Just getting the stuff.
All right,
So,
I'll get you the stuff.
question for Will. Will, what about making this stuff in like a home basement, or is this something that I briefly looked at the material safety data sheet, and I'm not sure that would be something I want to do in my house or in my kitchen. Is
Right.
is that a mistaken perception?
You definitely probably want like a fume hood for sure to just be able to vent out anything like any toxic fumes. The PEI stuff, it does have the means in it. So if that means if you do heat this and it does start like giving off volatiles, you don't want to expose yourself to it, or at least have like a respirator like in the open, like in a garage setting or something where air can go flow through as well. That's definitely a concern, yeah. But here in the lab, we have like all that stuff, the fume hoods, all the safety equipment. So.
Okay, and does that go for the MOFs too, metal oxide frameworks?
Yes, definitely. Most certainly. Yeah. That's definitely one issue because some of these amines, you start with the actual liquid version of it. So those are just volatile automatically. And when we were doing the gram scale synthesis this last semester with the DAG team, I had them, we were all just doing it within the fume hood with everything. Because you can, even when you open up some of these solvents, you can just smell it right away. And it's, if you were in a closed, like in your basement, you just be breathing all that in. So yeah, definitely. That's a concern.
Yeah,
Do
you
we-
just have to bring out your inner Walter White from Breaking Bad.
Yeah.
All my old COVID masks and
Breaking Bad.
respirators.
Yeah.
Yeah.
All right.
Do we have any options that is more like garage or basement friendly sorbents?
I would say the PEI is actually a much safer than the MOF stuff that we were trying to synthesize in the spring. Just because it's kind of like a gel. So I do have jars of this, of the PEI, and I've never worked with it personally, but we do have it here in our own lab. But that one, when you like open it up, if you're working with it, you should be okay if you're like outside or in a garage setting where there's airflow. Nothing volatile really coming off of it. But of course, it's always like exposure. It's like I personally wear gloves, mask, all that stuff, just to make sure you're not as exposed to it. With the MOF stuff, you definitely want to be in the lab setting for sure.
Okay.
All right. Thank you.
Good. And again, the long-term vision for this, if we create something that's relatively universal platform, then you'd have varieties or flavors of different kinds of sorbents that people will be able to use based on their interests and what they have at their disposal. So what we got to then, Will, was we had this idea of just simply using the existing thing that we have and inserting a monolith, or if it was a different shape, it could be something like this that could even be inserted into that 4-inch width that we currently have with our system. But when we started to look at this, we said, well, okay, the basic form function is workable here, but what else can we buy off the shelf that more or less does the same thing that might give us better sort of dimensions? So I started looking at this a few weeks ago, but really took a deep dive into it this week. And so from the same vendor, from HVAC Quick, who sold us the first one, we could get another one which has a sort of a wider area, and it also has a 6-inch duct as well. And it has this sort of interesting thing that you could insert in. That's a HEPA filter, in the front, and then a MERV 11 filter in the back. And I thought that that's quite hackable, actually, where we could even. I'm just going to show two different options here, where we want to fix we would need to have a different heating approach, where it wouldn't be thermo or wouldn't be nichrome, in the actual, sorbent. It would be an external heat source very proximate to the sorbent. And Ling was sort of talking about the different things we could consider there in terms of convective and conductive and stuff like that, which I'll let her elaborate on. But I think that one thing that could be kind of cool is that's now a 6-inch sorbent cartridge instead of a 4. So it would allow us to get more sorbent in it. And then could we slide something in there heating wise right next to it that would heat it up well? And so those types of filters, you could buy ones that are metal framed, rather than a kind of a floppy plastic one. And this is the kind of thing where we could, potentially, if we wanted to do something like we were doing, you could do, a nichrome wire, running up and down next to it. And there's a lot of other coil heaters and things like that I was even just went way too down a rabbit hole around microwaves and stuff like that today. But that is one kind of easy way we could do it. And then it would, look like this. You'd have during the absorption phase, you'd turn the fan on, dampers open, and then you would, during desorption, close the dampers, turn on the heat. And then another thing I thought is if we wanted to make our own heating element like that, because we're concerned about the distribution of the heat, could you do something that's more like a 1-inch and put them on both sides of the sorbent monoliths so that there's more sort of uniform heating? Now, the thing I want to show in a second, I think, is even a better option because it's easier to do and it'll probably be better heating. But before I do that, I'm curious if Ling, Jay, anybody here, Will or Charles, have any thoughts on what I just showed?
Yeah, I have a lot of thoughts. Chris, we did talk about convective versus conductive heating in person, and I pushed very hard toward convective heating. We don't want to do conductive heating because it won't circulate the heat very well, and so the center of the monolith will have a hard time getting the heat, and like and like it might damage the sorbent that's like directly next to the heating surface, because we're looking for something like 80 or 90 Celsius, which is pretty high. Another consideration is that I thought we're using the original duct to maybe save money or to like stay consistent with the shape. But if we're gonna change, we should just change to something else, because I was thinking about how to do heating like last night, this morning, and I think because the space that we're trying to heat is so big, we should something that we want to think about is just still stick with nichrome wires, but now use a fan to help recirculate the air inside. And if we're gonna change the housing, we should just change something to something else entirely, because these ducts are conductive, like heat conductive, and we're gonna lose a lot of heat. by continuing to use them. If we're gonna swap, then we should swap entirely. And if we're not gonna swap, then we'll just try to heat aggressively to make up for it. But we may need to look into lining the inside with some insulating material.
Yeah, I was going to show you that. I had a thought on that, that very thing. So, well, curious if other people have thoughts on that. And what kind of device? So Nichrome, we would continue to use that. What you're saying, but how would that actually, in terms of fitting it into the system, like what
We
kind
don't put it next to the monoliths. We use a fan to recirculate the air entirely throughout the
But
inside.
where would you put the heating thing though? In any event, like where would it actually go?
In one of the large spaces, just like in the middle of it, and then we would blow the air through it to push the hot air toward the other side.
Okay. Would this still work though if we did a 2-inch and you had, let's say, the Nichrome? It's not directly touching it, but it fits in. And
As long as it allows the air to go through, because I'm not sure what heating surface you have here, but if it's like a Peltier or something, that'd be really hard. But if it's like wires or like if it's wires where the heat can go through like a net, then that should work. I would like to hear from other people as well.
Question.
Sorry.
Yeah, go ahead, Jay.
So when you're in the desorb phase, you have all the dampers closed. If you use, is there enough air in there to blow around to heat it up?
Yes, I thought about that. So I'm thinking that we don't use a huge fan, because when you have a huge fan, you have no pressure outlet, right? And so we would use a smaller fan. So it's kind of like a convection oven with a fan inside. We wouldn't blow like with a giant fan that covers up the cross section area. We would just blow like in a portion, and then it would push on one side and then come back on the other side.
Yeah. Oh, convection oven is a good analogy. I think that might work.
Yeah.
Can we try it? Can we make a model and give it a try?
I think it would be good to try it in the current thing, even without anything inside, to see if the temperature can get up in the space without like anything in the middle. That would be interesting.
Yeah. It would be good to have like an array of temperature sensors so you can kind of see how the heat is distributed.
Mm-hmm. Yeah.
Okay. Thank you. Yeah.
Go ahead, Will.
Yeah, I just wanted to ask a quick kind of the clarification first. So you had mentioned the HEPA filter, right? And then also ducts, or I think I might be confused as to which one's which. There's the filter, the HEPA filter, and then there's ducts that you're thinking of getting rid of. Is that what I'm getting?
Yeah. So basically, the duct is the hole on the side there that the damper is attached to. You can see with the 3M tape around it. It's just a 6-inch circle.
Mm-hmm.
And then it goes into what's called a filter box, this sort of bulbous conical part.
Yeah.
That's all one unit. You bolt together, that has the two cones on the both sides. Mm-hmm. So the issue with this one, which we could still use this, because even what I just described, using a monolith, you could fit a monolith. We want to repurpose the one we have at UPenn, but if we're building the next one, is there ways that we could buy something that's related to that would also potentially have more space for more sorbent to fit in, and it also would create a less of I guess what's it called, a void factor, which another thing that Kirsch mentioned, that there's so much not dead air in that space that it removes the need for a vacuum, which is very appealing to us. So
okay, yeah. So my other question was going to be so I do like the idea about convection, just using hot air and flowing it through to heat it up, because that would be a concern with using. I'm not familiar too much with nichrome wire necessarily, but yeah, just having the heating element directly onto the actual sorbent itself could be a definite issue. So the airflow, heating with air, that seems really good. But the other question I was going to have was, if we go with that HEPA filter as like kind of like almost like the more cost-effective alternative to like the monolith? Because that's what we're thinking right now, right? It's like how the
Oh,
filter would
sorry.
be.
The what we do is we put the HEPA filter is just more to tell us what's the space and does it kind of create a frame, whether we make one our own, but it's more just to be aware of like what does fit into there in a normal space for this, and we'd put the monoliths in that thing.
Gotcha.
So I'm actually not team HEPA filter housing because I think it's paper and we're gonna have to gut that thing and it's gonna be a lot of work. I think we can just stack monoliths inside.
Exactly. Yep. That was the other thing I was sort of thinking is if we just had the monoliths in it, something like this, you could see sort of 4x4. This was an idea that I had a while ago, and then Kirsch thought it might be a good one. This is conductive heating though, but these silicone heat strips, which could get actually quite hot, and to be able to insulate the inside of it with silicone foam, and then just to sort of coat the surfaces with it. Might be an option, but we also does not need to be an option. But I do think the stacking of the monoliths is probably the better way to do it.
Okay, I'm not understanding the silicone. Let's see. So silicone foam that looks like insulating material.
Yeah, these are the
heating
pads, and then there's a kind of a foam strip that's meant for its insulation material. So you'd put the insulation on the back of the foam so that it's not directly contacting the metal.
I think it'd be good to have this to help maintain heat, but it won't be able to do all the work.
Yeah, it would maintain heat too if it could keep it in there. I'm also worried about just like, what do we have to put on the outside of this, like some sort of blanket or something, because that'll be quite hot to the top.
Yeah.
You know what I mean? But anyway, Will, does this make sense so far?
Yes.
Yeah. And I thought just, again, not an engineer or scientist, but just this idea of getting a lot in there. I wonder if in this smaller space, if there's even circular, there's circular heat fans that I found, that it would be interesting to see if, like, could you put one of those on the inside of a damper that has spokes that are far apart enough, or whatever they call them, that when the other fan is blowing through, it doesn't block it so much. You know what I mean? Air is able to pass through, but when you close the dampers, you're then able to turn it on, and it fits nicely into that space that's already unoccupied, that it could just blow hot air into it. I don't know.
We don't want the heating fan to be the same cross-section area as the dampers. We don't want it to cover that whole area. If we do, then it'll be hard for the air to recirculate inside. We want it to only be like in a manner of speaking, like in a corner of that cavity, so that it will push the air in a circular fashion versus a linear fashion. Because right now it's going, like in the diagrams that you're showing now, it's going from like left to right, or right to left or something. But instead we don't want that, because the dampers will be closed when this happens and the fan will not be able to push any air.
Yeah. Well, what are good ways?
We're gonna have to mount it somewhere else, just like in the space.
Yeah. In the space there. Does anything kind of come to mind? I mean, there's that one thing that Kirsch had shown that was like a coil electric filter that he thought, or a heater that he thought might work.
So the heating element. So I was looking up what we should be using, and I'm not like a really veteran expert on this. I think nichrome wires will be the most efficient and cheap at heating. And then for fan, we can buy something off of McMaster. They have, so here's a potential problem that we may run into is fans that can withstand the temperature that we need it to be at, because we can't just stick a computer fan inside. McMaster has fans that can go up to like 87 degrees, and I don't know if that's risky. So if we can find a fan that has higher heat tolerance, that would be good. I'm not like I'm not an expert on fans, but I just know that we need to account for the temperature requirement. And we don't want it to be too big either. We want it to be like something like the size of a computer fan, so that because like in the oven, you've seen ovens that have a fan in the back, right? That helps recirculate the air. Those fans work differently because there's a cavity outside of just like the oven cavity that you see. It pulls air. I think it pulls air out of the fans pulls air out of the oven and then it goes through another cavity outside and then puts it back into the oven from somewhere else in the cavity. We can't do that exactly, but we can imitate it. We can imitate that idea.
Yeah. I think on our old microwave, the magnetron blew out, and I replaced it, and I think the fan was belt driven, so the thing that ran the motor wasn't in the heat chamber. It was just the fan blades were inside the oven by the heater, and the actual motor drive was somewhere below it. So we could always put the motor outside and drive it through a shaft or some other way.
Right.
So it
Yeah.
doesn't, so that would
If
make
we
it
can do that.
mechanically a little more complicated, but it would maybe reduce the
Extend the
requirement
life.
the temperature on the motor.
Yeah. Yeah, the motor will probably go through a lot of stress.
Yeah.
So
Can
I don't know.
ask a quick
Yeah,
question?
go for it. Yep.
So during the desorption cycle, when we're heating this, are we thinking of having this to be a closed, like it's sealed off, or is this going to be open to an exhaust? Because the pressure should build as we're heating this, because we should ideally be like desorbing the CO2 or something, right? And at least from my understanding, I think it's supposed to be open to some exhaust, right? Is that what we're thinking, or no?
Oh, I don't know the answer to that question.
Because
Don't we want to
right now,
capture it? We want to
right,
capture it in some way in a
Yeah.
tank or something.
right, and I think there's a
Huh.
big issue with. I like the idea of recirculating the air circularly around it to instead of like a linear way, but also I think there might be an issue with just having it closed off because if it's a circular if it's circulation in a circular fashion or whatever airflow in a circular fashion, then any CO2 that comes off, it might just come right back onto the material anyway because it's kind of going in a loop. At least that's my thinking. I'm not super certain on this. This is definitely more of like an engineering question, but I think we might need like a linear flow with the heat and then open to an exhaust, and then that exhaust will go somewhere to collect it. Am I making sense? I hope.
Yeah. I think right now we're not incorporating a vacuum, but like eventually I think that's what people do in many cases. Okay. Yeah, I think I don't understand enough about like carbon capture, and after so many years, it's kind of embarrassing actually. But I'm imagining like this gentle recirculation, and then if the heat expands the air, then we can have an outlet somewhere where it collects into a collection chamber.
Mhm.
It's like an Instapot or something. We need like like a thing that goes like, and opens up. But yeah, we do want to capture it. I just don't know.
Yeah, we don't have a grand plan in mind.
Yeah.
But I think if we can capture a little bit right now and analyze what we get, that would be amazing. Because I mean, this is a volunteer project, so we haven't even gotten there.
Right. Okay. Yeah, I'm just imagining like some kind of CO2 sensor on like some kind of exhaust port or some like outlet port while it's heating, and then we can monitor the CO2, like just some concentration of CO2 coming out, and then it could literally just go into like some bottle and just collect it in there, something that's vacuumed out, and then just say this is what we collected, because that's kind of at least the final. That's like part of the overall picture, at least, which should be part of the desorption for sure when it's heating, I guess. Yeah.
Yeah, I think right now what we have built is just in the outlet. And then before, what we're looking at is we have a sensor at the like near the inlet, a sensor near the outlet. And what we're hoping is that when we get to the outlet, the amount of carbon dioxide would be lower there, and we might be seeing that, but the data is also not so consistent yet. So that's our like baby step.
I kind of envisioned that we'd have a tank that we'd pump down to a vacuum, heat the sorbent in the fan chamber, let the pressure increase until it stops increasing, and then open the valve into the tank to capture all that CO2 and start the cycle over again. What we do with the stuff in the tank, where we put that again, I don't know.
Mhm. That
Yeah.
seems like a great idea, though. That does.
Yeah, I think that's the vision. We had diagrammed this out at some point, but we just like we're people who built this. They're not here today. Well, at least one of them is sometimes on this call. He didn't really have that many hours to put in. He put in a lot of hours, actually.
Ton of hours, yeah. But then he had
Yeah,
to
but it was still not enough because this is like a full-time thing if you want to
Yeah.
fully
Yeah.
build it.
which is why I'm excited to get one going in Austin.
Mhm.
Because then, we have
Yeah,
access to it. There's multiple people. There's even other people, Will, that you probably know that we could invite to come take a look at it. It'd be fun to get some of the, Climeworks guys, and what I mean. Like I think
That'd be
it could
awesome.
we could develop quite a scene around it. I think, given the Net Club, and there's a lot of continuity there. Where the people who built the first one were not UPenn faculty or employees. We just were able to get space in there because their lab thought it was a cool idea, but it's kind of locked us out a little bit.
Yeah.
So by having our own that we can always just play around with whatever we want to, is a big upgrade, in and of itself. But we have had this idea. We had the first one, Will, it's like fastened to like a U-line cart, like a heavy duty sort of industrial plastic cart. And we've always looked at, the Epiphyte goes on the top floor, the top of it. Then on the bottom is the fun part where we had like an enclosed tank that, we thought of, Ben was working with algae. I love the idea of putting some kind of a, something that could do mineralization, like brucite was a thing that Kirsch recommended, that we're ultimately able to integrate mineralization, AKA storage, into the unit itself. But right now, just to get it catch and release is totally fine until we figure that part out. But, that's the direction we're going to want to go in. But we just got to get this good enough version where we can start promoting and get people building it all over the place, and then people can kind of play around with different ideas as we go.
Oh, okay. So is that kind of like another major goal of it? Is that this will be something we start, but it's kind of like the focal point where everyone else can look at our small design and then build their own, hopefully,
totally,
and then grow from there.
I mean, what I would like to have this very thing, which is small now because we have a GitHub repo, which Ling and another member, Christina, and Ling's sister, really have made into great working order. But we don't want to yet sort of. There's many universities that we've already talked to and students that are like would love to build one of these all over the world, right? But we first want to get it to it's more functional than it currently is before we sort of promote that, right?
Gotcha.
But yeah, the idea is you have Epiphyte teams all over the world building it, and that on a consistent basis, we're continuing to hack it and try to make it better, and to have different sort of design challenges at different times, whether it's around storage or making it, lower energy or developing a LCA. And then another member of our team was on vacation, Seth. What he really wants to kind of take on is how do we have a digital dashboard where we're monitoring the performance of these units. You can go to the website, you can look what all the different Epiphytes are doing collectively, and you could also see like, oh, well, this one seems to be performing really well. Why is this an outlier? You know what I mean? And so to really have it be sort of like a distributed evolutionary community that can keep accelerating this.
That's so cool. Yeah, I think that's actually possible. If we can build something that is like quote unquote easy enough to build with a small team at wherever university, then it can everyone will be different, right? And everyone can add their own different flavor on it, and then that'd be really cool to see where each person goes. Yeah,
that's the whole idea. Yeah. So So that's where we currently are. But I see. I think it sounds we're locked in on the monolith approach. Will be exciting to talk to you, Will, about what we want to kind of do as our next sort of sorbent. Whether it's something that you're cooking up or something we just want to buy from Sigma that we know will work. But just kind of figuring out this heating part. And I think maybe Ling and we could talk about this and see if we can get thoughts from other people. But I think if we get to a product on that, where we want to put it within the chamber, we're not too far off from being able to start scheduling. Okay, well, when do we want to sort of start ordering some stuff and building? So I think we're getting close. And now the students are getting back. So and I got the money to buy it. So we're getting to that point.
We should get everyone on the same page, like all the engineers. So David, Seth, maybe Christina. I don't know who else attends. Yokin. I'll think about like some bomb items.
Yeah, please do. Just maybe what we'll do is I'll share the picture of the thing that when Kirsch looked at what we had in terms of what we were trying to fit in, he had this one that was like I think I showed it was like a coil that went up and down so air could flow through it, and it wasn't really big. So you could see it being backed up a little bit into the chamber in the existing space. But if you want to take a look at a couple of other things, then maybe we can kind of throw those on the screen next week and just kind of weigh the pros and cons of it, the knowns and unknowns, and hopefully that'll get us closer to a decision. None of the ones that I've looked at are particularly expensive either. So we could even look at let's buy a couple and sort of test 2 out or something, as long as they can fit within it.
Okay. If you can, with Kirsch's help, find a web page, like a product page for that coil thing, so I can take a look at it. That'd be good.
Yeah.
Anytime.
Yep, I can send it to you on the Discord. There's a whole bunch of them. They're quite common.
Okay.
It was called High Watt Inc. was the name of the company. I'll just pop it into the comments here, Ling, just in case anybody else is listening also wants to. So it's just 1 second in the comments here. All right, cool. That was what he was thinking about. The thing I just put in there, which I can even just real quickly show since we still have a few minutes. This one here. So something kind of like this one, I presume, that you can see, there's the 3 that are next to each other. You can see the one that's on the bottom right is, kind of popping up.
Too. It'll be cleaner, cleaner than random nichrome wires, just loose. Or
Yeah, nichrome wires getting
a rack.
Yeah. Yeah, definitely. All right, cool. All right, guys. I think that's good. And what I'll do is, Will, I'm going to ping you, but I don't know what your week is like next week, but I'd love to meet you in person if you're around. I'm in Windsor Park, but I can come down to the university.
Oh, certainly.
So just Chris, before you go, David and I were chatting back and forth. I went through the bill of materials and put the electrical power dissipation for each component, what I thought the duty cycle was, how long each part would be on for the cycle, and came up with about 300 watts of power per cycle. David said that he was measuring around 380. So if you round that up to say 400, that's about 120 grams of CO2 generated per kilowatt hour, using grid power, average grid power. So that means that the amount of sorbent we need has to be capture more than 120 grams. Maybe I suggested 10 times that, and that turns out to be 5 kilograms of the sorbent he's using now. Maybe that doesn't work, but you get the idea that the power dissipation of this thing is really, really critical. Places where we could improve things is the power supply is only 88% efficient. And so a more efficient power supply would be good, and a heating system that's on for a shorter amount of time would be ways to optimize or minimize the amount of CO2 this generates while it's on grid power.
So this, I like what you're thinking here. So you, Jay, are going to be our designated LCA ombudsman. Just
LCA?
the life cycle. I mean, you're really talking about how much
yeah.
is this going to use
Yeah.
and stuff like that. So
Yeah.
as we've said, that will be absolutely a constraint under which we operate. And this kind of leads into a question that J3ALX, I don't know if it's pronounced Jags or whatever, that kind of speaks right directly to the kind of the heart of what we're trying to do here, is that we don't want to think so much about use cases right off the bat. But if you can make something that's simple and functional and universal again, then that allows users of it and hackers of it to discover their own use case. And I think the best metaphor for that is almost, I'm a solar guy. I'm always talking about it. There was something creative inherent to solar because it was so simple that it allowed people to think about how to use it in a variety of different ways, not the people who made it, right? So the installers of whether they were in rural India or putting it on a calculator in a factory in China or, on a rooftop on a Walmart, those ideas did not come from the producer of the technology. They came from the people who implemented it. And that's really a huge part. Legos are maybe even the best example. You buy your Lego kit to build the thing, but if anybody's a real Lego enthusiast, you're doing it so that you can make your own damn thing with it. You know what I mean? So that's why we want to kind of think about it along those lines. But anyway, I offered there in the thing, if you have a, any interest in joining us on this side, join our Discord and ping me. I'd love to meet you in person and have you be able to speak on this side of the screen.
We're just normal people.
I wouldn't go that far, Ling. I don't know about that. But,
so this is 120 watt. What is it? 120 watt hour battery, and so it'd be great if we could get an Epiphyte to run on this all day. That's the kind of thing that would be. And then you could charge this on a 100 watt solar panel. That kind of thing would be a goal for Epiphyte.
Yeah, that is an interesting thing. That could be a whole build where you say, okay, the next thing is this is the constraint. It needs to run, only on X battery or whatever like that, and see how people do at it. But we want to get to base one, I guess, while not painting ourselves into a corner where such an aspiration would be impossible because we went down a road that was too energy intensive. So. All right. So anyway, my kids are not back to school yet, so I have to go feed them. But great conversation, guys. I'm so excited to build the next one to do it here in Texas. Great input from J3ANX. Again, I'm probably an obvious way to pronounce that, but appreciate your thoughtful responses. We'll see you guys. And Will, I'll give you a call for coffee.
Sounds good.
All right. Bye, guys.